2.3 Trigonometry! Finding Lang.
Wicka wicka fresh. As DJ Tibbs stated, we're going to be finding lengths with, of course, trigonometry today. Here's how it's going to go down.
Well, to find lengths or angles of any triangle, we need to have a minimum of 3 pieces of information. Usually, one of those pieces of information is that it's in fact a right angle triangle, so we have that 90 degrees given to us, so we need 2 additional pieces. Previously, we were given those 2 additional pieces as 2 side lengths. However, we could actually be given 1 side length and 1 angle to then solve for a different side length. At that point, 1 side length is always needed. We can't just be given all 3 angles. That would be no bueno for us. So we will always need to know the length of at least 1 side. But given another angle, we could find another side length. And here's how we do it. It's a 6-step process, but it's really not that long. So don't fret. We good. Step 1, we're going to just choose an angle to work with. Right? We're going to always be choosing an angle that's not a right angle. So it's any of the 2 acute angles. We're just going to choose one. Step 2, we're going to label the sides according to that angle we've chosen. Right? Which ones are opposite, adjacent, and hypotenuse. Step 3, we're going to know what sides we're working with. So given the information, what sides are we using? And then we're going to write down the definition of the trig ratio. We're going to fill in the known values, and then we're going to isolate. So it's really not too many steps, but we can try it all out in an example.
Yeah.
So, taking a look at this dude over here. Step 1 is we're going to choose an angle to work with. Right? I'm not going to choose my 90-degree angle. I'm going to choose one of the other 2, so this one or this one here. Because my 45 degrees is given to me, I choose you.
Pikachu.
Now, step 2, label all the sides according to that angle. So I know that my hypotenuse will always be my longest side, which is opposite the 90 degree. Opposite to my 45 degrees is this one here. And adjacent to my 45 is over here. Now, step 3 is, well, what sides are we working with? Well, I'm given X and I'm given 20. I'm going to be now working with my opposite and my adjacent sides, which means if I have my OA, I'm going to be looking at my TOA of my SOHCAHTOA. So I know that I'm going to be using my tangent ratio. Now, step 4, write down the definition of the appropriate trigonometric ratio. Well, in this case, I have my tan. Note that it's not of theta anymore because I actually know what that angle is. So I have tan of 45 degrees is equal to my opposite, which is my x, over my adjacent, which is 20. And again, if we're wondering where that came from, well, we have tan of the angle is my opposite over my adjacent. I just plugged in all of those values. So my angle in this case is my 45, my opposite is my x, my adjacent is my 20. Alrighty. Now, we are going to isolate the remaining variable and compute. So we want to get x all alone. When we are solving for a variable, that variable has to be in my numerator. I can't really solve for my variable when it's in the denominator, but luckily it is in the numerator, so we all good here. Well, how do I get x alone? Right now, x is being divided by 20. To undo division, I use multiplication. If I do that to one side, I have to do it to the other. This leaves me with x on my right-hand side, and on my left-hand side, this leaves me with 20 tan of 45 degrees. And I'm going to plug that into my calculator. And when I do so, I end up with x is equal to 20. Notice that in the question, it tells me that I have to round to the nearest tenth. So that will give me 20.0. Keep in mind, I want to look at units for this particular variable. This is not an angle. So I know before we were ending off with our little degree signs, but x in this particular case refers to a side length. My side lengths don't have any particular units. If they had centimeters or meters or feet or inches there, I would indicate that. But I am not putting a degree sign unless I'm talking about an angle. In this case, we are solving for a side length. And I am done here. So x is 20.0.
Neat. I will take this next one. What? So could you. So,
Can you?
yeah. So give this a try. Do all the pausing and going forward. There are a few more examples on this. But try this one. I'm going to go ahead. I'm looking at this being my opposite side, this being my hypotenuse, and this being my adjacent. All based on this 38-degree angle. Not based on this. I'm not working with this. This, I don't know. This gives me troubles. It tries to lead me down the path of wrong. So, with 30 degrees, I'm working with my adjacent side and my hypotenuse. I'm not working with my opposite. Opposite tells me nothing. So, goodbye, opposite. And since I'm working with the I'm going to use the ka of SOHCAHTOA and say that cos theta is adjacent over hypotenuse. You don't have to state this. I like to. That's just me. Classic me. I'm going to fill in what I know. I know that the angle is 38 degrees. My adjacent side is x. My hypotenuse is 14. And if I really want to isolate x, which I should want to do, I'll take 14 times each side. So I can say that x is 14 times the cosine of 38 degrees and get a value out of that. Note, I'm not multiplying 38 times 14. I'm not saying it's cosine of this. 38 does not exist on its own as a number on this side. It is attached to the cosine and it cannot be separated. So cosine of 38 is its own number and we're multiplying that number by 14, which in this case gives us 11.03, but to the nearest tenth, that's just 11.0. Should I put a box around this? Nah, I won't.
In terms of showing your work, what steps do you need to show? Whoa, that was weird.
That was.
What steps do you need to show? You need to show your initial plugging in step. You need to show your isolating for your variable step and your final answer step, just as before. So you need to have a minimum of those 3 steps present. Alrighty. Try this one on your own as well. I'm glad you already did. Beauty. In this question, we are dealing with this angle here, which is 22.6. I'm going to go ahead and label all of my sides according to that specific angle. I know my hypotenuse is always my longest side, opposite my 90-degree angle. Opposite to my 22.6 is my x. Well, that's not a no. Opposite. And adjacent to my 22.6 degrees is this side here. Now, I want to look at which trigonometric ratio I'm going to be using. Which one provides me information? Well, I know I have my hypotenuse of my opposite. So I'm going to be using my SO of my trig ratios. I have sine of theta is my opposite over hypotenuse. And I'm going to plug in my known values. Instead of theta, I know that's 22.6 degrees. Keep in mind, every time we're plugging an angle, you have to have that degree sign. It is not okay not to include it, even throughout your work, because otherwise that would give you a units error. So beware. My opposite side in this case is x, and my hypotenuse would be 13. I am trying to solve for my x right now to be being divided by 13. To undo that division, I'm multiplying by 13. If I do it to one side, I have to do it to both. So I end up with x is equal to 13 multiplied by the sine of 22.6 degrees. Okay? And when I beep boop bop that into my calculator, to the nearest tenth, I get 5.0. I'm going to box that and pass her on.
Okay. And the last before we see some more words on the page again is this one. So, dealing with this angle of 67 degrees. This is not my hypotenuse. That would be bad. My hypotenuse is way over here. So this one's actually my opposite side because my angle opens to the opposite. This is my adjacent. So I'm using... So I'm going to play with tan. And I can say that tan of 67 degrees is the side opposite 67, which is x, over the side adjacent to the 67, and that's 19. And once again, isolating. I'm going to multiply both these sides by 19, and I can say that x is 19 times tan of 67 degrees, which in this particular case is like 44.76, but rounding wise to the nearest tenth, 44.8. And this thing be done. So in those examples, we always had our variable in the numerator. There. Variables in numerator, variables in numerator. Hooray, huzzah. And that was straightforward enough. Yeah. Nailed it. In this next one, and the one after it, we've got the variable in the denominator. So what on earth do we do?
Well, I'm glad you asked. Well, all of our first steps remain the same. So let's go as we normally would, and take a look at this guy here.
Okay.
So, based on this angle, my 36.9, my x is going to be my hypotenuse, this guy is going to be my opposite, and my 8 is going to be my adjacent. The ones that I care about in this particular case are my because they provide me information. So I'm going to be using the ka of my SOHCAHTOA, and that would be the cosine of 36.9 degrees will give me my adjacent, which is 8, over my hypotenuse, which is x. And this is the particular case that Mr. A was referring to. I now have my variable in the denominator. Something that you cannot do. I'm going to do it in red because it's so bad and so wrong and just so...
horrendous.
Unbelievable. That just don't do this. Do not do the following.
Don't do it.
Right now, you're like, I have 8 on the top. Let me just divide both sides by 8. No! Because this would give me my cosine of 36.9 degrees over 8 is still 1 over x. That does not mean that this is just equal to x. That is not equal. It is wrong. It is just horrifying in every single way. So we're going to get rid of all that and try not to have nightmares as such.
It's too late.
But we're going to deal with it in a much more, teal, turquoisey kind of fashion. When we are solving for a variable, it has to be in the numerator. Okay? Has to. Well, how do I get x into the numerator? Right now, this side is being divided by x. What we can do is we can multiply both sides by x to bring it up. So here we did so, and I end up with x times the cosine of 36.9 degrees is equal to 8. Now my x is in my numerator, and I'm feeling a lot more calm and happy and at peace with it.
This is nice.
But it's still not isolated. right now x is being multiplied by the cosine of 36.9 degrees. To undo that multiplication, we are going to divide both sides by the cosine of 36.9 degrees. Okay? When we do that, we are left with x is equal to 8 divided by the cosine of 36.9 degrees. And again, we're feeling a lot better about this. Yeah? Mm-hmm. We could go ahead and plug this into our calculator, and we should end up with x is equal to 10.0. In terms of steps that you need to show, okay, you need to show again that original plugging in values to our original trig ratio. We need to show the step of isolating my unknown, and I need to show that final answer. This step I personally show all the time, but it is not necessary in terms of showing all of your work. So as long as you have the exact same steps as we were talking about before, plugging in your values to the trigonometric ratio, isolating your unknown, and then your final answer, that would be A-okay with us.
Yeah. I'm going to do this other example with the same sense of calm. My 48 degrees. This side is my opposite. Here I have my adjacent. I will set this up with the tan ratio and say that the tan of 48 degrees is the opposite side, 17, over my adjacent, which is x. I will also show that multiplication step where we multiplied both sides by x, leaving me with x times the tan of 48 degrees being equal to 17, and I will isolate the x by saying I'm going to divide by that thing we were multiplying it by. I'm not just dividing by 48, because that does not exist on its own, but by tan 48. So if x is 17 divided by tan of 48 degrees, I get a value, and in this case, it's 15.3. This one is done. Now it is worth always checking if your answers do make sense. Like in this case, we got 15.3, which is smaller than that 17. Does that make sense that this side is smaller than that one? I'm going to say yes. Why? Who knows for us right now? We'll probably talk about it in a future unit. This one, where we said that this hypotenuse must be 10, which is bigger than this other side, which is 8, for sure that makes sense because we know the hypotenuse has to be the longest side. In this case, this bigger angle will open to a bigger side, and this angle, which is smaller, will open to a smaller side. But we will again talk about that more in future times. Did somebody put a box around this answer? I did. Oh, what's this?
Oh, it looks like there's some textbook practice for you to do. Oh, more calm, more serenity. There will be a quiz coming up soon. Yay.
Yeah.
Just prepare for us to talk about when that's going to be in class. Otherwise, we look forward to seeing you next lesson. Have a wonderful math-filled day.
Yeah, have a wonderful, peaceful math day.
Okay, bye.
Bye.